Okay, we're going to look at some more indefinite integrals, and we're just going to make these examples a wee bit more complicated than what you've seen before. Okay, so let's start with an example 1. Example 1, let's go with, we're going to integrate the square root of x. Okay, so very similar to differentiation, you need to prepare to integrate. Remember that the square root of x is x to the 1/2. Okay, I can then integrate it, add 1 to the power, 1/2 plus 1, so that's 1/2 plus 2/2 is 3/2. Divide by your new power and add the constant of integration. Okay, we're going to bring that up and flip it over and multiply, so that's going to be 2/3 x to the 3/2 plus c. Now, what we're going to start to do now is reintroduce the square root symbol. So at that point you've picked up full marks, but if the question is then looking for you to make a substitution, and without a calculator for that matter, you're really better introducing the square root symbol, so let's get used to doing that just now. So that's going to be the square root of x all cubed plus c. So I would encourage you to get in the habit of trying to put the square root symbol back into things when you're done. Okay, example 2. We're going to integrate 7 lots of the 4th root of x to the power 5. Okay, so first of all, prepare to integrate. Now for preparing to integrate, you can continue to put the integral sign in. You only get rid of that when you've actually went ahead and integrated. That's when you add 1 to the power divided by the new power. Okay, so that's going to be 7 lots of x to the power 5/4 dx. Add 1 to the power, divide by my new power, add 1 the constant of integration. Okay, so 5/4 plus, well, 5/4 of a pizza plus a full pizza is 5/4 plus 4/4, that's 9/4. So I've got 7x to the 9/4 divided by 9/4 plus c. Okay, I'm going to bring that up, multiply, so that means I'm flipping it over, so it's going to be 4/9 of 7x to the 9/4 plus c. Okay, 7 4s are 28, 20/9, can that be simplified? No, it can't, but I'm checking it. 28/9 times the 4th root of x brought to the power 9 plus c. Okay, example 3. We're going to integrate 5/x to the 7. Okay, same rules as differentiation. If the variable rather is down bottom in the fraction, we need to bring it up. So I'm just preparing to integrate here. That will be 5x to the minus 7. That's the reciprocal rule. 1/a to the n is equal to a to the minus n. Okay, add 1 to the power, divide by my new power, so that's 5x to the minus 6 divided by minus 6 plus c. Okay, so that's, doesn't matter if the minus is there or there, it means the same thing, so minus 5/6 x to the minus 6 plus c. Now at that point you've definitely picked up full marks, but if it's a substitution question without a calculator, I'm going to look to bring that back down and make it positive, so it's going to be minus 5/6x to the positive 6 plus c. Okay, example 4. Okay, example 4, let's go for this one. We're going to integrate 5/7x to the 3. Okay, prepare to integrate, bring that up, and that'll be 5/7 x to the minus 3. Add 1 in my power, divide by new power. I'm going to come up here now, so that's going to be 5/7x to the minus 2 divided by minus 2 plus c. Okay, now you can think of that as minus 2/1. Bring it up and flip it. So that's going to be minus 1/2 times 5/7 x to the minus 2 plus c. So that's minus 5/14 x to the minus 2 plus c. Final move, bring that down. That's going to be minus 5/14 x squared plus c. Okay, example 5. I'm going to integrate dx over the square root of x. Okay, now let's just have a wee think about what this means. If you've got 1/4 times 3, well, another way of writing that is 3/4. Well, if you've got 1 over root x times dx, another way of writing that is dx over root x. So that really just means there's a 1 up there, 1 over root x dx, and that's maybe a more intuitive way to think about that one. Okay, but if it gets presented to you in that way, it's looking for you to know that you can write it in that way to get yourself going with the question. Okay, root x can now be written as x to the 1/2. I'm still preparing, I'm going to bring that up, and that's going to be x to the minus 1/2. I'm now going to integrate, add 1 in the power, divide by my new power, so minus 1/2 plus 1 is minus 1/2 plus 2/2, so that's 1/2, so that's x to the 1/2 divided by 1/2 plus c. Okay, flip that over, that's going to be 2 over 1 x to the 1/2 plus c. That's 2 times the square root of x plus c, final answer. Okay, example 6. I'm going to integrate, let's go for a kind of awkward one this time, minus 7 over the 5th root of x cubed dx. Okay, let's start to prepare then. So that's minus 7 over x to the 3 over 5 dx. Still prepare and bring that up. So it's going to be minus 7x to the minus 3 over 5 dx. I'm now going to integrate. Add 1 in the power, divide by new power. Okay, so minus 3/5 plus 1 is minus 3/5 plus 5/5, that's 2/5. So I've got minus 7x to the 2/5 divided by 2/5 plus the constant integration. Bring that up and flip it over, so that's going to be 5/2 times minus 7x to the 2/5 plus c. Okay, so that's minus 35 over 2x with the 5th root of x squared plus c. Check if the fraction can be simplified. It can't. Final answer. Okay, example 7. I'm going to integrate t plus 3 squared. Okay, get rid of that bracket, open that up, that will be t squared plus 6t plus 9. I'm going to integrate that. The reason why I'm wrapping a bracket around that is to show that this dt, which is an indicator that you're going to integrate, is affecting each term. Okay, so what do you do now? Just integrate the 3 terms in turn. So that's going to be t cubed over 3. The number's up there, even though you can't see it, it is 1 plus 6t squared over 2 plus, well, think about if you differentiate 9x, you get 9. If you differentiate 9t, you get 9. So that means if you integrate 9, you must get 9t plus the constant of integration. Okay, final thing, can you simplify it? And you can. 6 divided by 2 is 3. So it's t cubed over 3 plus 3t squared plus 9t plus c. Final answer.